Current is the flow of electrons through a medium. And we look at that current flow by taking the most minuscule slice, if we can visualize that theoretically, of a piece of copper, for instance, in an electrical circuit. And the number of electrons that pass through that hair's thin piece of material per second defines the current flow in that particular substance. We refer to current with the capital letter I in the algebraic equations when we're working with any type of voltage. When we look at I in the quadrant, I is in its relationship to be able to find I can be done with power, with resistance, and voltage. One of the things that we always talk about is the higher the current, the higher the impact is on the work that can be done. So that's the more electrons that are moving through that particular medium that gives it some extra energy. I was always told when I was a young telephone man, it's not the voltage that will kill you, it's the current. Which is true, because you can take 160 volts of DC energy with a 3/8 amp input on it, and the current will not hurt you as much as if it had been twice that high, and that can be painful. So we refer to current as amps, and that's amps is a abbreviation of ampere, which is a French term for the number of electrons moving past that thin slice. We can measure current with a volt-ohm meter, and by doing so, we would take the meter and put it in series with the circuit and monitor the number of electrons that actually pass through that thin slice of medium, but we're going to use our meter as the registering tool to tell us how many electrons are going through that, and we will know how many amps that we have. Most circuits are designed to take a particular type of amperage load. If it's too high, if the electrons are moving at a higher rate than anticipated, it can damage a circuit. So when you see a fuse that is rated for a particular value, for instance, in your home, your breaker box in your electrical panel have 15 and 20 amp breakers. If the electrical draw, the current is higher than what it is registered for, i.e. 20 amps, that breaker closes such that no electricity and no current can flow to those outlets, because it can be damage within the circuit, or, as we'll know from discussing Ohm's law, that it will heat the circuit with the electrons passing at too high of a rate through the transmission medium.
Vizy Online Texts are a new kind of textbook. Our original content uses animations, simulations, video and graphics, self-assessments, exercises, and review materials to engage students in their study. Our approach is proven to improve learning outcomes, and that's why Vizy exists, to transform lives by making education more engaging.